Hi guys, good evening. Am I audible to all of you? Can you please confirm in the chat? Hi guys. So I think I'm audible, I'm visible, and thanks for joining. So finally guys, it's happening. We'll try to do some amazing things, okay, on my channel. So what you just need to do, you just need to be with me and try to join regular basis. So definitely I'll try to cover everything, okay, whatever you need from my side at least. So welcome guys, welcome to our new playlist, live playlist called Computer Visions for Developers. First of all, I want to tell you why I have started this computer vision, okay, playlist at the very first on my channel, okay. Uh, See, there is a reason behind it because see, everywhere if you see people are talking about Gen AI, so that's why I decided to start computer visions because what I feel like still in the market there is a huge demand, okay, we'll find inside the computer vision domain. Because now computer vision is also utilized inside GenAI because whatever large language model you can see nowadays, okay, it is coming in the market, so it is a kind of multi-model. So at the end they're using computer vision architecture in the backend also. So if you're uploading any image, if you're uploading any videos, so again your model will able to understand actually what you want to do exactly with the data, right? So at the end if you want to understand these are the like complex architecture, okay, at that means the LLM architecture, so you should have foundation of computer visions, okay. Otherwise it would be a little bit difficult for you to okay, understand what is going on inside that. Even I have also planned like I'll try to cover some vision transformer model, okay, in this series, so that you will at least get some idea how things are working, how they are combining the computer vision architecture with these kinds of, let's say, NLP architecture, and they're creating a hybrid model and they're handling all kinds of data, right? So guys, it just is starting. I'm promising you I'll try to complete each and everything in detail. So whatever things you need to know, okay, to master computer visions, definitely I'm going to teach you everything. And this is not only going to be a theoretical understanding. Simultaneously I will also try to show you the practical development. We'll be building some amazing project. We are not only going to build the project on our Jupyter notebook or let's say Google Colab. Even I'm going to show you how we can use our real-time camera, how we can create the user app, everything we'll try to develop. Even I will also show you how we can deploy it, okay. So recently I think you saw I have uploaded one video on my channel. So there I developed one automatic robotics arm with the help of real-time computer vision. So many people were asking me, sir, how you have developed these kinds of things and how you used actually computer vision technology there, okay. So because of that I started this playlist because I know that there are many let's say learners are there, okay, they are interested about computer visions, they want to explore the computer visions, okay, they want to learn different kinds of things like how we can do the classification, detection, tracking, even how we can use these kinds of real time, let's say okay, technology with these kinds of real world projects, okay. So everything I'll give you the idea guys, all kinds of KT I'm going to give you. Just try to join regular basis and try to support me, try to support my channel, okay. And if you need anything, okay, from my side guys, please let me know. Definitely I'll try to bring the content on my channel. So I think you know that guys, recently I quit my job because I want to now dedicate my most of the time on my YouTube channel because you have connected me, okay, it's been long and you have lots of expectation from my side too, right? So that's why I have decided to make the content regular basis on the channel, and I will provide like very high quality, good quality content, okay. That is my promise, okay. Yeah. So fine guys, I think we can start now our first episode, so the introduction to computer visions. And again I'm okay, welcome you to my playlist Computer Visions for Developers, okay. So those who have already joined, thank you so much, and please try to share it also with your friends and family if they're interested. Please try to give the opportunity, okay, so that also they can learn, okay, with my playlist. And just hit the like, guys. Okay, if you want this kinds of session more, please hit the like. And if you haven't subscribed to my channel, please try to subscribe, because I have seen there are many people, they watch my content but they don't subscribe, okay, to my channel. I don't know why. So if you're liking, so definitely please try to subscribe, try to support, and try to share with your friends and family. Okay, great. So before starting the session, guys, first of all, I'm going to show you the agenda, like through the entire, let's say, playlist. Okay, that means whatever class I'm going to take, what are the topic actually I'm going to cover inside computer visions. Okay, let me write down step by step. Okay, then I'm going to also show you what are the requirements actually I need from your side, at least to go through this particular playlist, so your understanding would be more clear. Okay, then I'm going to start from the introduction to computer vision today, right? Great. So for this, I'm going to open up my Blackboard. So let me open up my Blackboard. And all the materials, guys, all the, let's say, handwritten notes, all the codes you will be getting to my GitHub. So let me show you my GitHub, guys. So this is my GitHub. If you search ENTBappy on Google, okay, ENTBappy. So this is my keyword. This is my alias name. So if you just search it on Google, you will be getting all of my profile. Okay. Not only that, you can also search like DSwithBappy. Okay, DSwithBappy. This is another keyword. You will be getting all of my profile. Okay, so these two keywords you can use, guys. If you want to figure out my social media, if you want to figure out my any kinds of thing, you can use these two keywords. So this is the like first website you will be getting, guys. Bappy Ahmed ENT. Okay, Bappy GitHub. Just try to open it up. So this is my GitHub profile. So here you can also do me follow me. Okay, because whatever repository I'm going to create, so definitely it will give you one update. So here I'm going to share all of the resources. Okay, so here I'm going to create a repository. In the repository section, I'm going to share all of the handwritten notes, all of the class materials. Okay, all of the, let's say, codes, everything I'm going to share here. Got it? Yeah. And the link would be mentioned in the description section, so from there you can check it out. Okay, yeah. I will update the link just after the session, because I haven't created any repo yet. I'll try to create, and whatever handwritten notes I'm going to write, guys, I'm going to share. Okay, here you can get it from here. Fine. So guys, let me know if this class timing is fine to all of you, because I know that there are so many like people are there, they're doing the jobs and all. So that's why I decided to start like 9:30 p.m. IST. So if it is works for you, let me know, guys. Is the time is fine, guys? And please try to interact with me, guys, because the intention behind this live session is so that I can interact with you, I can talk with you. Okay, otherwise I could have recorded the video and I can upload it, okay, in my channel. I don't have any issue, but there you cannot communicate with me. Always there is a fun in the live class. Okay, what I feel like. Okay, so please try to comment. Yeah, so great. So please try to comment and try to ask the questions. That's how I can communicate, I can interact with you, so our class would be more interactive. Okay, otherwise I will feel like I'm recording the sessions and kinds of thing. Kindly make a video on Onyx and Tensor etc. Next one. Hamid Reza definitely will try to create Onyx as well. Onyx, I think playlist I am already having in my channel. You can check it out. So you can see I'm having lots of playlist. Okay, so here I think Onyx is there. I created long back, but I don't know like whether there is dependency change or not, but you can check it out. This Onyx Open Neural Networks Exchange. Okay. Otherwise I will create a fresh one. Okay. All right. And this is the playlist, guys. You can see if you go to my YouTube channel, if you click here playlist section, so this is the playlist computer visions for developers. So all the recording would be updated here. Okay, all the recording would be updated here. So today is the episode 1, so you can see after the session it would be updated here. Can we use first RCNN with DeepSort for object tracking? I will show you more good approach, okay, for the object tracking, Atul. No need to worry, okay. Fine. So guys, now what I will do, first of all, let me open up my Blackboard. GNAI live course. I think GNAI, I think 22 hours of course is already available over my channel. You can check it out. So here is the course GNAI. So you can see, you can check it out. And if you need the live course on top of GNAI, like with Agentic AI MCP, definitely I can think about it. Okay, after the computer vision. Kundu. Okay, great. So let's start, guys. So first of all, here let me clarify the agenda. Just give me 5 minutes. I'll try to clarify first of all the agenda. So here we are starting computer vision. Okay, guys, am I audible? Let me know, am I audible, guys? Or sorry, I think I disconnected. See, it's a like a online session, so definitely there would be some connection issue. So don't leave. Okay, just try to stay here.
Let me know,
Somehow
am I
I will.
audible, guys?
I'll try to come back. Okay, somehow I'll try to connect. Just don't go anywhere. So sometimes it happens because of the internet issue and all. Okay, yeah. So I think now everything is fine. Now I think I can start, right? Okay. See what I was telling, why I have named this for developers. Okay, computer vision for developers, because here the way actually I'm going to complete the entire playlist, so that any kinds of, okay, any kinds of person can develop any kinds of applications in the field of computer vision, whether it's a classification applications, whether it's a object detection applications, whether it's a image segmentation application, whether it's a tracking applications, whether it's a, let's say, face recognition, key point detection, any kinds of, okay, any kinds of applications you can see in the field of computer vision you can develop. Okay, so that's why I am named it for computer visions for developers. Got it. So here the first thing, we'll try to start from the introduction definitely. So today is the introduction part. Introduction to computer vision. Then next we'll try to discuss about image processing. Okay, image processing. So image processing is important because at the end you have to work with image and videos, and you have to know how to process that. So for this we'll be learning some amazing library like OpenCV. Okay, OpenCV will try to learn. There is another one called Pilo. Okay, but if you see, the most used one is OpenCV nowadays if you're working in the field of computer vision. So that's why we'll be more focusing on the OpenCV library. Okay, then once image understanding is clear, let's say image processing is we have learned, then we'll try to start with the major component of computer vision, which is nothing but convolutional neural network. Okay, convolution. Okay, convolution neural network. Okay, network. And we'll be learning different CNN architecture. CNN architecture with practical, okay, practical hands-on. Then I'll be discussing about transfer learning, because at the end you will be working with transfer learning only. Okay, transfer learning. So transfer learning, and we'll be talking about pre-trained model, pre-trained SOTA model. SOTA model. SOTA means state of the art model. Okay, the model you can use for your development. So anywhere you can deploy these kinds of, let's say, model. Even I'm also going to show you some other model, okay, that you can also use. But for this you need like higher infrastructure, okay, to deploy these kinds of model. Then once everything, all the basics is clear, okay, because inside convolutional let's say neural network, we have some concept like CNN, then max pooling, okay, stride. So these are the like basic concept we'll try to understand. Even we'll try to see how back propagation happens in the convolutions, okay, convolutional layer. We'll try to understand each and everything. We'll try to break down the concept, guys, and we'll try to understand each and everything. So this is just a high level walkthrough I'm giving, okay, what are the, let's say, a topic I'm going to cover here. Okay, so that means the theoretical understanding you need on top of the CNN, that means convolutional neural network, I'll try to give all the idea. Okay, no need to worry. Then once everything is clear, guys, I'll try to start with something called object classification task. So inside object classification, we'll try to see some practical, even we'll also explore some models like ResNet, VG16, Inception. Okay, then there are some other models are also available. Okay, we'll try to explore all of them and we'll be building some amazing applications. Okay, then once object classification is done, I'm going to start something called object detection. Everything is important, guys. Whenever you are building the applications, everything is important. Object classification is important, object detection is important, object segmentation is important. Okay, tracking is important, everything is important, because the application I have developed, I think you remember, so in my YouTube channel, I think it is there. So if I go to the video sections, so here is the application, guys. I think, let me show you.
Pasar a liderar un...
Let me skip the app. So see, guys, this is the applications. I think you can see the demo. So here what is happening, whenever I'm sending the QR code, so here is the camera, guys. Okay, so camera is first of all analyzing the object. Okay, that means it is doing the detection. It is trying to understand what kinds of object it is. Then on top of that, I think you can see the QR code. Okay, so QR code is also getting recognized. So that means here we are using multiple tasks. Here we are not solving this particular problem with the help of only one task. We are using multiple tasks at the end. Okay, then after that, here we are sending again, my robotics arm is picking up this one. Okay, so that means everything is happening with a multitasking. Okay, with the multitasking. It's not like that I'm only using object detection, I'm only using, let's say, QR code recognitions. It's not like that. Everything you have to combine. You have to learn how we can combine different things and we can build this kinds of amazing product. Okay, so whenever you are creating like end-to-end product, real world product, so that means you are combining all the tasks together and you are making something big. Okay, you have to divide the task, then you have to like add them together. That's how one end-to-end solution will try to build up. Okay, yeah, what is convolution, I'll tell you. Okay, cool boy, I'll tell you what is convolution. Also, this is not the agenda for today. I'll give you the detailed idea about the convolution. Okay, thank you for the amazing course. Thank you, Faisal Mia, thank you so much. Yeah, so yes, so that's why we need, guys, all kinds of understanding like object detection, object segmentations. Okay, everything we have to learn here. And object detection, you will see there are different models for the object detection. We'll try to explore all of them. Then once object detection is done, we'll try to start something called image segmentation. Okay, image segmentation. We'll try to explore all kinds of image segmentation. Then we'll start something called key point detection. You can also call this as pose estimation. We'll try to also explore. Then after that, we'll try to explore something called facial recognition. So this is super important thing, guys, because there are so many applications you have to also build up in future, so that will use your facial data. And for facial recognition, we use completely different architecture. I'll tell you how facial recognition happens. We'll try to build some amazing project. Okay, your understanding would be more clear. So then we'll also explore something called OCR. That means optical character recognizer. Okay, so I think nowadays you have seen, like, if I open up my ChatGPT camera and if I take a pictures, like it will extract the text from that. How it is happening? Because internally it is using OCR. And if you open like Gemini and if you open the live camera also, okay, so at the end it is using OCR to extract all of the, let's say, data from the images. So at the end everyone is using computer vision only, right? So if you are working in the field of computer science, guys, computer vision definitely you have to use at the end. So that's why what I feel like this is super important technology. So I know that like there are many people, they're ignoring the computer vision, but what I feel like this is the most demandable and this is the like most used actually, let's say, domain. Okay, what I feel like, if you go anywhere, let's say in future maybe some other technology will come, but computer vision would be used there, because at the end we have the camera, right? we are generating the image, we are generating the videos. So definitely computer vision should be there. Got it? So that's why we have to learn that. Then I will start with some tools you need. Like we'll try to export the YOLO, Detectron. We'll export TensorFlow. We'll export PyTorch. Okay, and so on. Some other tools I'm going to also show you. Then I'm going to discuss about the real world CV project. Okay, implementations. Then we'll also learn deployment. I'm also going to give you some idea how we can deploy these kinds of let's say things to the edge devices also. Like I think you saw I implemented one project, robotics projects, there I was using microcontrollers. Okay, so how we can do it, okay, I'll also let you know that. Then we'll try to also discuss about some latest trends, like okay, like we have vision transformer. Okay, transformers are there. Then I'm going to also discuss about multi model. Okay, multi model and much more. Okay, so this is the entire agenda, guys. Okay, through our entire playlist. Now let me know, guys, if anything I'm missing. Okay, sorry, I think I haven't added the object tracking. Sorry guys, I think it should add there. I forget to add. So let's consider object tracking as well. So here I'll write object tracking. Object tracking. Okay, tracking should be there. Then one thing I will also tell you, the GANs. Okay, generative adversarial networks. Now if anything I'm missing, guys, let me know. Anything I'm missing inside computer vision, let me know. If you tell, I'll cover. If you don't tell, I'll not cover. Am I missing anything? Thank you, Suresh. Thank you so much. As of now, these are the topics I am getting in my mind. That's why I've written down everything. Apart from that, if anything is left, guys, let me know. Okay, then one thing I'm going to also teach you. Self-driving car. Okay. Self-driving car will try to also implement. Okay. VAE. So maybe we'll understand this thing in the vision transformer. Okay. It will live class. Yeah, it would be live class. Okay. On my YouTube channel. And now you can ask me the class whether it would be regular basis or there are some specific date. See, I'll try to conduct regular basis, but if something, let's say, happens, let's say if I have some like emergency works and all, okay, I'm not able to take the class, that time I'll try to like reschedule. So how you'll get the update, guys? Always you have to check here. Okay, always you have to check in the live sections. Okay, just go to the playlist and here you will see the schedule of my class. Okay, so there it will show you the times and date, okay, when my next class will come. But I'll try to conduct regular basis. Okay, regular basis will try to cover. Yeah, diffusion model. Let's also write diffusion model. Okay, so people are talking about diffusion model. I will also write it. Diffusion model. Diffusions model. Yeah, we'll also cover that. Yeah, I think that's it. Inside computer vision, nothing else. Thank you all of you. Thank you. So guys, please give me a quick like in the chat. Any kinds of emoji, just send it. If everything is okay so far, did you get the entire agenda? Can I start with the introduction? Let me know. Give me a quick thumbs up on anything, any emoji. 3D vision, reconstructions. Okay, we'll also explore that later on after completing the let's say all the topics. We'll try to also go to the 3D image processing part. Okay, I'll give you some idea. Yeah, prerequisite and programming language. I'll tell you. Okay. Yeah. So let me just write down the prerequisite. What is the prerequisite? Prerequisite. So prerequisite wise, the first thing I'm expecting, guys, from all of you, Python programming. Okay, this is not going to, I mean, give you, what? Yeah. So everywhere you will go, you have to learn the Python. Okay. So Python programming. Python programming is definitely required. If you don't know Python programming, I have one amazing playlist on my YouTube channel. Let me show you. Amazing playlist. Okay. I don't know why views are not coming here because I think there are so many Python playlists are available. But if you go through my one, I have created. So here, let me show you Python for AI. Okay. So just trust me, guys. If you go through this playlist, okay, uh, you will be like pro in Python. Okay, that is my promise. So here I have covered everything. Okay, everything you need for the Python, for the OP, for the, let's say, modular codings. Okay, everything I have shown with the real-time examples. So if you go through one more time, let's say if you want to if you need a quick revision, guys, you can go through because it's a small video at the end. If you complete, let's say, at least 3 to 4 video per day, so it would be a quick revision for you, and I promise that, guys. Okay, you will be loving this series a lot. Okay, so if you are new to the Python, guys, please try to like refer this particular playlist. Okay, Python for AI. Got it. All right, then the next prerequisite I'm expecting, deep learning. Basics of deep learning. At least basics of deep learning, you should have knowledge on neural network. If you don't have the knowledge, guys, on deep learning, it's completely fine. Okay, I'll take care of the part. Okay, the way I'm going to explain the things, you will be able to understand. But if you have the deep learning knowledge, little bit about of deep learning knowledge, okay, so it would be easy for you to understand the theory part. But practical wise, everybody can understand. Okay, practical wise, I'll try to make sure everybody can understand, everybody can develop the projects with me. Okay, that is my promise. But theory wise, if you have the deep learning knowledge, okay, the artificial neural network concept, so it will help you to understand. And all the CNN part, I'll try to take care. Hmm. Shofik is telling nice class. Thank you so much for giving such a course. Thank you so much, Shofik. Just keep sharing, keep liking, keep subscribing. All right. So this is the prerequisite. Duration of this course. See, I can't tell you the exact duration because I have mentioned so many topics now. So now let's see. Okay, how many days it covers. Okay. Unless and until I'm not covering everything, I'm going to take the class. Okay. Hmm. After completion, any opportunity for jobs, see, just try to learn this thing, okay, and try to build some amazing project. Try to share it with your social media. Automatically, you will be getting opportunity, right? People are waiting for good developers. Okay, so if you share something, if you build something amazing, definitely you will be getting lots of opportunity, right? And you can also keep applying for different organizations, those who are working with computer visions. So yeah. Okay, so now let's start, guys, for our very first sessions called Introduction to Computer Vision. So the way I'm going to give you the introductions, okay, I think this will make you understand, okay, each and everything inside computer vision. Even I will try to also compare the computer vision with our real world, let's say, analogy. That means the way human actually, let's say, sees any kinds of image, any kinds of videos, and they process with his brain. Okay, I'll try to compare each and everything. Yeah. So for this, I'm going to open up a PPT. Let me open up the PPT and let me show you the introduction part. All right. So see, guys, what is computer vision exactly? So this is just a simple definition. computer vision enables a machine or a computer to have a vision system close to humans. Okay, I think everybody can understand this definition, what is trying to say. If you don't understand, just try to see the diagram. So see what happens, human vision system. Okay, so whenever, let's say, we see any objects, how we see, okay, we have eye. Okay, we have eye. So first of all, we'll try to see the object. Okay, our eye will capture this object and it will try to send a signal to the brain, and brain will try to process like what kinds of object it is, because we have already trained, okay, we have already trained with lots of objects in the world, right, as a human being. Okay, let's say whenever you just came to the world, okay, let's say whenever you are the kids, that time you had like very less knowledge, okay, about the objects, about the let's say activity, whatever we have in the world. But slowly, whenever, let's say, you are growing up, you are learning each and everything. Now, let's say this is cat, this is dog, this is horse, and somebody is training you. Somebody is training you, and your brain is trying to process, okay, and it is remembering those are the objects. Yes or no? Right? So that's how human learns anything. So whenever he sees anything, first of all, he gets some train from other person. Let's say let's say there is a kid, so he hasn't seen, let's say, horse before. So that kid will try to tell his father like what kinds of, let's say, animal it is. His father will tell it is a horse. So next time whenever he will see the horse, definitely he will be able to remember, because his brain has processed, okay, and it has remembered. Okay, then he will give the output like it's a cat, it's a dog, or it's a horse. Okay, these kinds of output he will try to provide. So that's actually human vision system works. Okay, now what about computer vision system? This is the same replica of human. Okay, you can see in computer vision system also we are having some input, and there we use something called sensing device. Okay, sensing device. What is sensing device? Sensing device is nothing but at the end this is your eye. Okay, this is your eye, and it is trying to send a signal where to the interpreting device. Interpreting device you can compare with the brain. Okay, that means it is trying to process, it is trying to remember. Then it is giving you one output, whether it's a cat, whether it's a dog, whether it's a horse, and so on. Clear? So this is the simple definition I can give to the computer visions. Okay, that means it enables machine or computer to have a vision system close to humans. Okay, now to implement this architecture, we have to follow some certain steps. Okay, we have to follow some certain steps. That thing we'll try to discuss. Now see how these kinds of computer vision works. First of all, you have to acquire the image or videos via cameras. Okay, if I want to collect any image or videos, I have to use cameras, and camera is nothing but our sensing device. So for me, my camera is my eye. Okay, if I want to get some data, definitely I'll try to use my eye. Then I'll try to send this particular image to my brain. That means interpreting device, my brain will try to process, it will remember, then I can show some output. Okay, so then what I will do, I'll try to process the captured visuals. That means you have to process, somehow you have to process, and for processing we have to use some technology. That thing I'm going to teach you through the entire course, right? Then analyzing, understanding the image and the content. So these three steps we usually follow in the field of computer visions. And all the three steps I'm going to break down, and I'm going to show you each and everything so that your understanding would be more clear. Okay? Fine. Now let's try to understand, okay, one thing. But before that, I want to just write something. Um, See, inside computer vision, inside computer vision, uh, we have some, let's say, task. Okay, so computer vision falls in the deep learning, DL. Okay, and in DL, I think you know that in deep learning we have some network. The first network we can talk about ANN. That means artificial neural network. Artificial neural network. Okay, network. Then we have CNN. That means convolutional. Okay, convolution neural, okay, network. Then we have something called RNN. ठीक है से RNN, that means recurrent recurrent neural network. Okay, recurrent neural network. Now ANN we use for the understanding of neural network. So this is the foundation. Okay, foundation. Okay, this is the foundation. So without understanding the ANN, you can't understand the CNN, you can't understand the RNN. So that means ANN is the foundation. Okay, and here we use some tabular data. Okay, structured data we try to use in the ANN. Okay, now whenever it comes to the unstructured data, or let's say image or video data, that time you can't use ANN. Okay, you can't use ANN, it won't be working that time. So for this you have to use some other architecture. So that time we'll try to move to the CNN. So that means whenever you are having image data, okay, image data, video data, okay, you have to use the CNN architecture. Okay, and all the architecture is belong to deep learning. Okay, in deep learning always remember we are having three kinds of architecture. The first one is ANN architecture, artificial neural network, and this is the foundation. It works with the structured data, tabular data. And then we have something called CNN, that is convolutional neural network. It works with the image data or video data. Then we have another network called RNN, and it works with something called unstructured text data. Okay, text data. And this is the field of NLP. Okay, here NLP comes into picture. Okay, but here we are learning something called computer vision, and computer falls into CNN, that is convolutional neural network. This is the foundation. Okay, and from the convolutional neural network, nowadays whatever task you do, object detection, image segmentation, key point detection, okay, all the advanced architecture came in the market, but this is the foundation at the end. Okay, you have to learn this particular foundation. And here there's a concept called feature extraction. So what happens? So at the end, what is image, guys? Tell me. At the end, what is image? So let's say I'm talking about an image. What is image exactly? Do you know that? So I'm getting some questions. What should be the minimum system configuration for the computer vision? At least you should have Core i5 processor with 8 GB RAM. Okay. Then good time. Okay, so hello, I have been following you last 3 years. I will suggest you playlist name like 100 days of computer vision. I'm a student, so that I know many people search like this. Yeah, so Patel, thanks for the suggestions. Next time definitely I'll try to do that. Okay. But let's see like how many class I usually take for completing. Okay, then based on that I'll try to decide. Yeah. Yeah, so what is image, guys? Image is nothing but it's a collection of pixels, right? So if I show you any image, let's say I'm copying one 8-digit image, or let's say I can show you one image, I think that would be fine. So let's say this image I'm showing you, this image, I think you can see the image. Okay, image is visible, guys, to all of you, right? So what is image exactly? Image is nothing but it's a collection of pixels. So see, if you zoom any kinds of image, what you will see this kinds of box. Okay, these kinds of box, and this box is nothing but it's a pixel. Okay, it is having some value. You can see 0 to 255, 0 to 255. So these are the values are available. That means whenever you are having higher number, that means close to 255, that means it's a white. Okay, it's a white, let's say, color. And whenever you are having the number close to 0, that means 0, so it would be black color. Okay, so that's how one image is built up. So now you can see this is the 8. Okay, 8 digit is written in the image. That's how. Okay, 8 digit. Sorry, let me just draw it perfectly. So see, this is called 8 digit. Okay, now okay, why it's not working? Just a minute. Let me take this one here. So you can see this is the 8. So okay, now here you can see what is this. Okay, some numbers now. So whenever you can see the white cell, that means there are some numbers. Okay, whenever you can see the black cell, that means there is 0. Okay, so that's how, if you consider any image, guys. Okay, if you consider any image, let's say I'm copying another image. Just a minute, guys. Let me maybe show you. Let's copy this image. I'm copying from Google, guys. Okay. So maybe you can see this image is visible, guys, I think, right? So see, let's say there is a dog image. Now for dog also, you can see if you zoom the image, you will be getting some pixels. Okay, you will be getting some pixels. And wherever you see the color, that means here are some numbers. Okay, and what is the number? It is 0 to 255. Okay, that means if it is close to 255, that means there is a color. Okay, and if it is close to 0, that means there is no color. That's how one image is built up, and you can see it is having a shape like that. Okay, it is having a shape. Okay, it is having a shape. And if you break down the shape, guys, you will be getting something called edge. Say small edge, let's say this kinds of edge, we call it as edge, guys. Okay, this is called edge. This is what, guys? This is edge. Okay, this is edge. Now here you can see we are having different edges. Okay, we are having like vertical edge, we are having horizontal edge, we are having this kinds of rotated edge, we are having again, let's say, this kinds of edge. Yes or no? Tell me yes or no. If you see here, we are having horizontal edge, we are having vertical edge, we are having rotating edge. Yes or no? And if I combine them, all of them together, what I will get? I will get a shape. What I will get, guys? I will get a shape like that. You can see this is the shape. If you combine all of them, here you will be getting a shape. Okay, here we will be getting a shape. Right. Now what you can understand, okay, from this particular demo, that means whenever, let's say, we see any object, our brain first of all try to capture the feature. What kinds of feature? This kinds of edge feature, edge. Okay, any kinds of object we see, let's say this is in front of me, there is a human. First of all, I'll try to understand the shape of the human. Then I can differentiate, this is a human. Let's say there is a dog in front of me. So I know how dog shapes actually. Okay, what is the dog shape? Dog shape is different, cat shape is different, human shape is different, car shape is different. All kinds of object is having different shapes. Okay, so first of all, my brain will try to extract the feature. Okay, we call it as a feature, guys. Okay, so this is called actually feature. Features. Okay, features. First of all, my brain will try to extract the features from the objects, these kinds of small edges. Then in the brain, there is another section that will combine all the edges together. It will make a shape. Okay, then there is another cell in my brain, okay, another part that will try to add the color. Then there is another cell that will add try to add the entire let's say visualization effect. Okay, that's how first of all you will processing. Okay, you are processing the shapes, you are processing the edge, then you are constructing the entire image, you are constructing the entire objects, then you are able to try understand, okay, what kinds of object is there. Okay, so that's how human brain works. Okay, I'll give you one amazing example, guys. I think from the example you will try to understand how this idea came first of all. Okay, how researcher got to know this idea. Okay, that's how we have to let's say do the image processing. Okay, so for this they did one cat experiment. Okay, I'll tell you. So first of all, let me open the this one, my PPT. See, let's try to first of all understand the CNN versus human visual cortex. Okay, that means in my brain. So let's say this is our brain, nah? This is our brain, and you know that those who are from like biological background, I think you know inside our brain there are different parts. Okay, so some of the parts is responsible for the let's say whatever listening we are doing. Some of the parts is responsible for thinking, some of the parts is responsible for visualizing any effect, some of the part is responsible for recognizing any, let's say, okay, object. So that's how we are having different parts, okay, inside a like brain. Okay, I think you know that, guys. Yes or no? Now let me take my pen and let me explain how things work. Just a minute. I'll take a new color. So let's say here you can see, guys, maybe you can see, okay, so this is the human brain, okay, and here you can see here is the eye. Okay, here what we have, guys, here we have the eye. Okay, that means here we have the retina. So inside eye we have the retina. I think you know that retina. Okay, so what happens, first of all, light will reflect to the retina. That means let's say there is an object, there is a cat. So first of all, how you will try to see the cat? Because of the light. I think you have already learned this thing in the physics, right? So light will reflect in the retina, then you will be able to see the cat. Okay, and this particular signal, okay, you can see there is a there is a optical nerve. Okay, what this called, guys? Optical nerve. Okay, optical nerve. We also call it as a axon. Axons. Okay, those who are from biological background, I think you know that we call it as an axon. Okay, so this particular signal will go through the axons. Okay, that means optical nerve, and it will reach to a point. This is called actually thalamus. Okay, thalamus. Okay, thalamus. So this is a section here your processing will be happening. That means the signal you are getting from the eyes, it will reach here, and this particular part will try to process the signal. Okay, what kinds of signal it is. Okay, what kinds of signal. That means here it will, what it will do, it will try to process the signal, then it will send the signal through this particular axons again. Okay, where to the here V1. Okay, V1 section of your brain. V1 section of your brain. Okay, that means what is happening here, you are doing the feature extraction. Okay, here you are trying to understand the shape of the, let's say, object, and this signal you are passing where to the another layer. Okay, another part of the brain, and it is trying to, okay, it is trying to consist everything, and it is trying to recognizing that particular objects. Okay, that's how human brains works. Got it, guys? So you can see there is a V1 section, catalog inputs. So here your signal will come, and this is our visual cortex area, guys. Okay, this is our visual cortex area. Got it? So see, in the brain there are 8 sections. Okay, you can see there is a V1, V2, then V3, VP, V4, V8, V7. Okay, there I think 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 sections are available inside a brain. Okay, all of the section is having their different responsibility. So here our visual cortex area is nothing but our V1. V1 will try to process your visual data always. Got it? Any questions? If you have any questions, let me know. Okay, now let's try to compare with the actual brain right now. So what I will do, try to go to the next slide. So let's say this is our actual brain CT scan. Okay, so you can see this is the actual brain CT scan. So here you have the eyes. Let's say here you have the eyes, because here you can see the brain na. So I think just behind that we have the eye. Okay, now what is happening? So here you have the what? Axon. Okay, axon. That means optical nerve. Okay, here you have the optical nerve. So first of all, whenever light is reflecting here, it will go to the retina. Retina will try to send the signal through the axons, and it will reach where? It will reach to the thalamus. So here you have the thalamus. So the previous example I showed you, it was the, let's say, one part of the brain. Now I'm showing you both part of the brain. Okay, now see this signal is coming where? To the thalamus. This is called thalamus. Thalamus. Okay, then from this axons again, this signal is going where? To the V1, that means visual cortex. So here you have the visual cortex, V1 section. Okay, V1 section. So that's how, guys, the entire human brain works. Okay, whenever it sees any kinds of object. Clear? I hope it is clear, all of you. Okay, so now let me clear and let me move to the next part. Now I'm going to show you one amazing experiment. Okay, 2 researchers did for understanding, okay, how our brain works. Okay, how it try to process the signals. Okay, and how it's try to identify different shapes of the objects. Okay, so the research came from the the idea came from this particular research only, guys. The research name is cat experiment. Okay, 2 researchers were there named Hubel and Wiesel. Okay, Hubel and Wiesel. So both are researchers. They did one cat experiment, and here is the video link. First of all, let me show you the video. I think by seeing the video, just a bit. First, okay, my Google Home Mini activated. So let me open the video. This is the link I've already added. So see, the research experiment name is Hubel and Wiesel 2 cat experiment. Okay, so like this is a very old video. I can see this guy has published in his YouTube channel. So let me show you the experiment. Okay, how things works. Just try to see carefully. See, they are doing the research. So what they did actually, they took one cat. Okay, you can see this is the cat. Okay, so they did the anesthesia to the cat. They gave the anesthesia to the cat. Okay, then they put one electrode in the brain of the cat. Okay, that means they inserted one electrode. I think you know electrode. Those who are from electronics background, I think you know electrode. What is electrode, guys? Do you know electrode? So electrode actually what it can does actually, it can take the electrical signal. Okay, it can, let's say, receive the electrical signal. Okay, electrode. So they put one electrode in the brain of the cat. So let me show you. You can see this is the experiment they are doing the setup. This is the projector actually. See, this is the setup, entire setup. I think it is not visible properly, but I will show you the diagram. Okay, I have one image diagram. With the help of that, I'll try to make you understand. You can see this is the cat. This is the entire setup. They did they give the anesthesia to the cat, and they put the electrode in the brain of the cat. Okay, that means this cat can, let's say, listen anything. This cat can, let's say, see anything. Okay, but it can't move. What is anesthesia means? Okay, you can see, you can listen everything, but you can't move. Okay, so that's how they did the entire setup. And this is the projector. So through the projector, they're showing some objects, okay, to the cat. You can see. See, this is the object. So some capture shapes actually, let's say round shapes, then horizontal shapes, vertical shape, these kinds of shapes, they were showing to the cat, okay, and they're trying to measure the signal from the cat brain. Okay, this is the experiment actually. See, that's how the entire experiment works. Now let's try to understand this experiment. Okay, I'll try to break down and try to make you understand. So here is the experiment, guys. See, so let's consider this is the setup. This is the entire setup of the cat experiment. I think you saw there was a cat. So let me show you. So I think you remember there was a cat. This is the cat, and they gave anesthesia to the cat. That means this cat can't move. And this is the electrode, guys. What is this? Is the electrode. Okay, electrode. They put the electrode in the brain. You can see in the brain of the cat. Okay, for recording the visual signal. Okay, for recording the visual signal. You can see recording from visual cortex. That means it has put this particular electrode to the visual cortex area. That means V1 section. I think remember there was a V1 section. They put in the V1 section, and here is the you can see oscilloscope image. Okay, here is the oscilloscope image. Let's say this is the V1 section, and this is the first tissue. Okay, this is the first tissue. There, putting the electrode. That means in the V1 you are having different tissues. Okay, different cells. Okay, different cells area. So let's say this is the first area. Let's say we call it as a C1. That means cell 1. Okay, so they selected this area and they put the electrode. Okay, electrode in the brain. Now what they are doing, with the help of projector, I think you saw one projector was there. Okay, with the help of projector, there, okay, showing some, let's say, shapes. They're showing some shapes on the display. Okay, and this cat is trying to see that. This cat is trying to see that. Let's say initially they're showing these kinds of horizontal, okay, horizontal shapes. Okay, and they're recording, real-time recording the brain signal. You can see there is no signal. Okay, there is no signal. That means the C1 cell they are using, this is not able to capture this kinds of horizontal signal. Then what they will do, then again they will change the electrode to the another cell, let's say C2. Okay, C2. Again it will change to the C2. Again they will show some kinds of shapes. Again they will record the signal. Again you can see there is no signal. Okay, what again they will do, again try to change the cell, let's say C3. Okay, then again they will try to show some shapes. Now you can see some signals are there. Okay, some signals are there. That means if I show these kinds of shapes, that means this particular cat is able to understand. That means this particular cell, let's say C3, is able to understand these kinds of shapes, these kinds of edge, these kinds of orientation edge. Okay, now if I give some more let's say oriented like that, some more signal I'm getting. If I'm giving completely vertical, now see there are more signal I'm getting. Okay, more signal I'm getting. That means this C3 is only responsible for recognizing these kinds of edges, these kinds of edges, these kinds of shape. Okay, that means C3 is only responsible for these kinds of shapes. Again, you will move to another cells. Again, you will see that some of the cells will try to recognize these kinds of shell. Some of the will try to cell will try to recognize these kinds of shapes. Some of the cell will try to recognize these kinds of shapes. Okay, that's how they did one experiment, and this is called cat experiment. Okay, and from this particular experiment, they got to know, okay, in our brain there are different okay, there are different cells. That means in the V1, that means visual cortex, there are different cells, and all the cells, okay, all the cells is responsible for recognizing different kinds of edges, different kinds of shapes. Okay, so this was the understanding from the entire experiment, guys. Okay, I hope it is clear, right? Okay, I hope it is clear. Now let's try to understand what is the outcome they got. Okay, so I'll go to the next slide. Yeah, see, as an outcome, they got two kinds of cell, okay, from the brain. One is the simple cell, okay, and another one is, let me show you. Yeah, another one is complex cell. Okay, two kinds of cell they got. So this is the, like, you can see some microscope image actually. Okay, so that's how these cells looks like. So I think this is the complex cell, and this is the sorry, this is the simple cell, and this is the complex cell. Okay, I don't know which one is the simple and complex, but at the end they got two kinds of cell. One is simple cells, another is complex cells. Okay, now we can also call these simple cells as orientation cell. Okay, orientation cell. Okay, or feature detector, feature detector, feature detector. Okay, and it has a smaller receptive field. Receptive field. What is smaller receptive field? That means it can only recognize small edges. That means these kinds of edges. Let's say these kinds of vertical edges, these kinds of rotated edges, these kinds of, let's say, horizontal edges. Okay, these kinds of, let's say, rotated edges. So these kinds of small edges, this can understand, these kinds of simple cell can understand. That's why it is having a smaller receptive field, and we call it as a orientation cell. That means feature extraction. Okay, then there is another cell called complex cell, and we call it as a bigger, okay, bigger receptive field. Receptive field. Okay, what is bigger receptive? Bigger receptive, what it will do, it will try to understand the big pattern from the edges. That means, I think I showed you one demo in my, yeah, here. So see, first of all, what is happening, you can see, whenever we try to see any object, first of all, my brain will try to process the small edges. Okay, small edges. Now if you combine all the small edges together, it will make a shape. Okay, it will make a complex shape like that. Okay, so that kinds of complex shape, if I show you, that kinds of complex shape, your complex cell will try to understand. Now let's say here I am having some edges, so I'll try to combine the edges. Let's say I'll try to combine like that. Okay, I'll try to combine like that. Okay, and like that, let's say I am getting a cat. Okay, I'm getting a cat. So this kinds of understanding your complex cell will try to do. That means inside a brain there are different cells, and all the cells is responsible for different kinds of pattern recognition, different kinds of edge recognition. And two kinds of cell works. One is the simple cell, one is the complex cell. Simple cell will try to understand the small edges. Complex cell will try to understand the big edges, big pattern. Okay, and that's how one object will try to consist, and it will try to recognize the entire objects you have in front of your eyes. Okay, that's how things work. I hope it is clear, guys. Okay, so from this particular idea, they came up with the first architecture. You can see this was the first architecture they developed. Okay, this was the first architecture they developed for the recognizing pattern. Now you can see here we have the pattern. So this is the pattern. So stage 1. Okay, in the stage 1 they are using simple cell. Simple cell, that means simple feature extractor. So this simple feature extractor, what it does, it will try to extract different edge. Like you can see in this particular pattern, we have this kinds of edge, this kinds of edge, this kinds of edge, right? So this is small edges it is trying to understand. Then stage 2, you can see it is using some complex cell. Complex cell, that means it is using some complex feature extractor. We can call it as a feature extractor also. Now it is trying to consist, these are the small edge, and it is making some bigger pattern, okay, like that. Then again in stage 3, they are using some more complex feature extractor, okay, feature extractor. So what it will do, it will try to again make something like that, okay, it will try to use and it will make something like that, okay. Then stage 4, it is using some more complex cell, and this particular complex cell will try to consist the entire pattern like that. It will be able to understand, okay, this is the recognized pattern, okay. That means there is a multiple steps it is following. First of all, it is going to the smaller simple cell, then going to complex cell, again more complex, then more complex, then it is able to understand the entire pattern, entire object you have in front of your eyes, okay. So this was the first architecture, guys, they proposed, okay, after doing this particular research, doing this particular cat research, okay. But there was a limitation, guys. This was like only for small, let's say very easy kinds of pattern recognition, but when it comes for the complex pattern, so it will fail that time. Then they came up with another, actually, let's say idea. Let me show you this particular architecture, okay. So I think there is a researcher, his name is Kunihiko Fukushima, okay. In 1978, he proposed one architecture. The architecture name is, let me show you, the architecture name is neocognitron, okay. Neocognitron is a hierarchical multi-layered artificial neural network proposed by Kunihiko Fukushima, okay. So maybe he was the Japanese scientist, so he proposed this particular architecture. Now here you can see he is also using, okay, some cells, okay. You can see cells S mane means this is the simple cell, and there is another one called cell C, that means this is the complex cell. That means initially they are using simple cell, then in the middle position, okay, that means as you go ahead you will see they are using complex cell, okay. That's how they're understanding the any kinds of image, okay. But again there were some limitation, okay, there were some limitation, it was not good. Then later on, okay, there was another researcher, I think you have already heard of his name, called Jan LeCun. Guys, do you know about Jan LeCun? Yes or no? Do you know Jan LeCun, guys? Maybe currently he is working with Meta, okay, Meta. So Jan LeCun was the first guy, guys. He proposed one architecture called Linet 5. Linet 5 is one of the earliest pre-trained models proposed by Jan LeCun and others in the year of 1998. In the research paper, this is the research paper, guys, they published, called Gradient Based Learning Applied to Document Recognitions, okay. So they created this particular architecture for document recognitions, okay. So let me show you the paper. So I think I have given the link. So see, this is the Jan LeCun paper they published, okay. URL not found, maybe they have removed, but you can search like Linet 5 research paper, gradient boosting learning. So this is the paper, guys, Linet 5. I'll be discussing about how Linet 5 they have built up, okay, what is the layer, everything I'll try to discuss, okay. As of now, see, this is the architecture. So that's how this architecture looks like. I can see you have some input image, and here it is using some convolutional layer, that means feature extractor, okay. And they're using some more layer. You can see they're using like pooling layer, okay, like subsampling. This is called pooling layer. Then again convolutional layer, okay, then fully collected layer. Then they're at the end recognizing these kinds of digit, okay, these kinds of, let's say, documents. I'll discuss each and everything, guys. What is like convolutional layer, what is max pooling layer, what is let's say fully connected layer, each and everything I'll try to discuss, okay. So as of now, just try to understand this was the architecture, guys. From here evaluation came, okay, from here evaluation came in the field of computer vision. Then different researchers, different company came up with different architecture. Like nowadays we use VGG16, ResNet 50, Inception V3, right? So all kinds of architecture came, and now people are using, okay, it for the image recognitions, okay. Got it? So how was the introduction, guys? Let me know. Did you get it? Yes or no? How was the introduction? I think you got it. Okay, great. Fine. Now let's try to understand uh, one thing. If I open up my Blackboard, yeah. So see, first we have to understand some things like what is object detection, classifications, and segmentation. Okay, what is the difference between them? Okay, otherwise you will have the confusion. Let's say we are having different kinds of tasks inside computer vision. Like we have object classification, we have object recognition, we have object let's say segmentation. Okay, what is the difference between them? For this, I'm going to show you one image. I think this image will make you the idea. So I think guys you can see the image, na? This image visible, right? Yeah, thank you, all of you. Yeah. So see guys, here is the difference between classification, object detection, and segmentation. Okay. See, in classification, what we do is just try to classify the image. Okay. Classify. Let's say here you have the image, here you have the objects, and here you are trying to classify. That means in the image, what kinds of object is present. So let's say here I have a cat. I have a cat, but I don't know where this cat is located. Image classification only will try to classify whether it is what kinds of object. Okay, but let's say there is another object. Let's say there is another object called dog. That time image classification fails actually. So what it will classify? Because at the end there are two kinds of objects. Okay, it can't classify two objects, right? It will only classify one object. That's why whenever you have only one object present, okay, inside the image, you will try to apply something called classification. And easily with the help of classification, you can classify what kinds of object it is, whether it's a dog, whether it's a cat. Then another things came into picture called classifications and localizations. Now this is deprecated actually, nobody uses deprecated. Okay, so it will try to locate the image location of the image. Okay, so see there is a cat, but in my classification there is no location, but now here you are getting the location where this cat is present. Okay, but it will not give, okay, it will not give like the detection real time. Okay, that's why we call it as a classification and localization, but this is deprecated, nobody uses. Then for this I mean on top of this classification and localization, one amazing concept has came called object detection. Now here what we do, let's say if we have multiple objects, okay, if we have multiple objects inside the image, we apply something called object detection, and it will create a bounding box like that. Okay, it will create a bounding box, okay, on top of different objects, and it will try to tell you real time. Let's say this is dog with a confidence call, let's say 70% confidence, this is a dog. This is the cat, let's say with a let's say 60% confidence, this is a cat. Okay, cat. So that's how it will try to locate, it will try to create the bounding box where your object is present. Even it will also give you the confidence score, how much your model is confident this particular object is dog and this particular object is cat. Okay, but there is another issue with the object detection. Let's say you need some accurate output, because you can see in object detection there are some other background is also coming, na, at the end other background is also coming. Okay, this other background is also coming. So if you don't need this kinds of background, that time you can apply something called instance segmentation. So what it will do guys, it will try to segment. You can see it is segmenting the object. It is not taking any kinds of background, it is trying to segment. See, and it is applying some mask on top of that. Okay, see, on top of some mask it is adding. So this is called segmentation. Okay, so can anybody tell me what is the real time application we are using for the segmentation? I think everyone is using, everyone has this let's say application. with you. Can you tell me one name of instance segmentation, guys? Anyone? Currently I'm using. Okay, currently I'm using with this live class. Let me know. Object eraser. Okay, that is also fine. But see, let me show you one amazing application. I think you already know that. I think you have used Zoom meeting, na? Zoom meeting, Google Meet. So there you can remove the background, you can add another background. Okay. So let me show you. I'm using one real-time application called NVIDIA Broadcast. Okay. So if I show you my preview, so see, here I have removed my background, guys. Okay. I have removed my background. So what it is doing, it is trying to segmenting me only, and rest of the thing it is removing. Okay. Even I can also add some other background. See, I can also add some other background. Okay, so how this thing is working, because of the segmentation, they're applying real-time segmentation here. They're trying to segmenting me and my chair, rest of the thing it is removing. Okay, and I can add some other background in the backend. Got it? Now let me just remove it. Okay, I don't want any background. Now let me just disable preview. Yeah, so this kinds of application is using, guys, this kinds of segmentation is using. Okay, so amazing use case. Now inside segmentation, you are having some part. Okay, let me show you. Some parts are available, some types are available exactly. See, you are having three kinds of segmentation type. So let's say this is your original image. This is your original image. Now the first type you are having called semantic segmentation. Okay, semantic segmentation. What semantic segmentation does, it will try to segment everything in the object. Let's say it will try to segment the car, then this traffic light, this building, this road, this like people, this sky, this trees, everything. You can see everything it is trying to segment. That means inside a frame, whatever objects you are having, everything it will try to segment with a different color. Let's say car will try to segment with a same color. Person will try to segment with the same color. This sky will try to segment with the same color. Building will try to let's say segment with the same color, and traffic light will try to segment in the same color. This is called semantic segmentation, guys. Okay, semantic segmentation. Then there is another one called instance segmentation. What instance segmentation does, it will only keep the objects. Okay, it will only keep the objects. Rest of the background it will remove. Okay, now I think you saw whenever I removed my background, guys. Whenever I removed my background, so what kinds of segmentation they're using? Tell me. Semantic or instance? I think I showed you NVIDIA broadcast, na? So there, what kinds of segmentation they're using? Instance or semantic? Tell me. Instance, right? Yeah. Okay, and in instance, actually, you'll see that all the object will have different colors. Okay. Yeah. All the object will have different color. Let's say car. It is car. It's completely fine, but all the color will have different color at the end. Okay. Yes. Then person is also. You can see all the person is having different color, and rest of the thing it has removed. Then there is another one called panoptic segmentation. Okay, what panoptic segmentation does, it will segment everything, but color would be different. Let's say car is color is having different, person is color is having different. Okay, sky it is different, again building you can see it's different. Okay, that means color is different, but in semantic color is same. Okay, but in panoptic color is different. This is the only difference. Okay, and instance will try to remove the background. Now see, semantic segmentation is applied in the autonomous vehicle. That means I can take self-driving car. Self-driving car. Okay. So this particular you can say technology you can apply. So let me tell you self-driving car. Car. What I can show you, simulation. can show you some simulation. Something about that, I think. Segmentation. Image segmentation, I can write. I saw some image, guys. Just a minute. So maybe this one is fine. This one I think you can say. Okay. You can see this is the application of semantic segmentation. So here, let's say whenever you build this kinds of self-driving car, so you have to segment everything, because at then with respect to all the object, your self-driving car will make the decision. Okay, it has to follow the traffic, it has to follow the pedestrian, it has to follow the road, it has to follow the sky. Okay, based on that it will try to decide where to move. Got it? But for these kinds of application, the Google Meet and NVIDIA broadcast we are using, we can use something called instance segmentation. Okay, you can either use panoptic segmentation for the self-driving car also. It is also fine. Okay. Yeah. Now I think you know, like computer vision application, like CV application. What we have, guys? We have self-driving car. Then we have facial recognition. Okay. Then we have, let's say, detection, any kinds of detection system, car number plate detection. Okay, I can write detection system. Then we have something called AR, that means augmented reality. Okay. Then I think you have also seen in the medical domain also this computer vision is used for these kinds of brain tumor segmentation and all. Have you seen, guys? Yeah, I think now voice is fine. Yeah. So maybe you have also seen these kinds of like device nowadays. Okay, in the medical industries, so they will do the brain CT scan and automatically it will try to segment the part actually you are having the cancer or let's say any kinds of disease. Have you seen, guys, this kinds of device, medical device? So here also like computer vision is also applied, right? Yeah, there are like thousands of application I can consider. Maybe you are mature enough to understand. Okay. Yep. Okay. Now let's discuss some challenges. Some challenges we also face whenever we're working in CV. The first challenges we get data acquisition and quality data. Okay, so whenever you are doing data collections and there is a part called annotation. Okay, you also need to perform annotation of your data, annotate the data. So that's why it is a little bit challenging, because here you have to do the manual labeling. Okay, manual annotation. Even some automation tool are also available. I'll also talk about that. Then data quality should be also good. Okay, then the second challenge will be getting the hardware. Okay, hardware, that means whenever you will be training this kinds of model or let's say fine tuning, you need some a good hardware. Let's say A100 GPU you need. Okay, V100 GPU you need. Okay, so that's how there are different configuration GPUs are available. You can also use multi-stack GPUs. Okay, with the help of that you can also train the model. But if you don't have this kinds of GPU, so training model would be a little bit difficult for you, because at the end image is like a complex data. It is having actually thousands pixels. Okay, and to process all the pixels, see at the end pixels is what? Pixels is nothing but it's a matrix, right? You can see it's a matrix. Let me show you, it's a matrix only. Matrix. Okay, and at the end you are doing the matrix multiplications, and I think you know that To do the matrix multiplication, what would be the computational power, right? So let's say dot product, I think you have heard of, then cross product. So these kinds of multiplication happens in the backend in our processor. So that's why hardware requirement is super important here. Okay, GPU you need. Okay, then the challenge you will get called proper knowledge of the domain. Okay, so let's say I have seen many people, they don't have the proper knowledge on this computer vision domain, but they want to, let's say, build the application. That time they feel some challenge. Okay, so that's why you should have first of all proper knowledge, okay, proper domain knowledge, computer vision, inside the computer vision. Then it would be easy for you to work in the computer vision. That's why I have mentioned all of the topic, guys. Okay, so this is the like proper domain knowledge. Once you get the proper domain knowledge, now then you can design any kinds of, okay, applications, whatever application you can think. Got it? Hmm. Yeah. And in computer vision, we usually use actually three kinds of image. Okay, image type. Let me just write image type. Image types. The first image you use something called black and white. Black, white. This is called grayscale image. Okay, so let me show you grayscale image how it looks like. Grayscale image. That means it is only having one channel. Okay, so this is called grayscale image. Okay, it is only having one channel. Then you have color image. Color image. Okay, color image is having three channel. Three channel. Okay, that means red, green, and blue, RGB. So let me show you color image channel. So see red, green, and blue. Okay, that's how color image looks like. Okay, so to process color image, you need more computation because it is having three channel. Okay, three matrix calculation you have to do at the end, but in grayscale you have only one matrix. Okay, that's why. Then you have another image called PNG. PNG. Okay, so PNG is having four channel. Four channel. One is like R, G, B. Other is like the alpha. That means the transparency. Okay, so I think here I can draw it like that. So let's say R, R, then G. Okay, then you have B. Oh, sorry, red, green. Sorry, guys, RGB, blue. It would be blue. Then you have another one called alpha. That means transparency. I can take any color. Okay, so this is R, this is G, and this is B, and this is nothing but my alpha. Transparency. Transparency. Okay, so these are the types actually we have inside the image. I hope it is clear to all of you. Okay, now you can ask me what is the video then. Okay, because in computer vision we also use video data. Video data. So what is video at the end, guys? Tell me, what is video? Video is nothing but it's a frame of image, let's say image frame. Okay, video is nothing but it's a image frame. Okay, let's say you are having different images. You are having different. Let's say this is the image, and let's say there is a footballer with a football. Okay, let's say this is the position P1. There is another image. Let's say this footballer is here, position 2. Then there is another image. This footballer, let's say again, he is in the middle position. Let's say this is P3. Now, if you see this image, okay, in a 30 FPS mode, frame per second, okay, you will feel like one video is going on. Okay, that means if you combine all of the image frame together, if you play it with a 30 FPS, that means frame per second, you will feel that something is moving. Okay, this is called actually video. That means at the end, whenever you have the video data, any kinds of video, okay, and if you want to apply computer vision on top of it, first of all, you have to convert to the image. Okay, you have to convert to the image frame. Okay, and on top of all the frame, you will try to apply all the processing. Okay, that means there is nothing different. Only you just need to convert this video to the frame, and all the operation you will try to apply on the frame. Then again, you will try to construct the video. Then you will show to the user. This is the idea, guys. Okay. Now you can either follow 30 FPS, either follow 60 FPS. Okay. Nowadays, I think 60 FPS people prefers. Okay, this is more good. Instead of 30 FPS, we can consider 60 FPS also. Clear? Tell me, guys, all of you. If you are clear, guys, so please write down clear in the chat, all of you. So this was the introduction to our computer vision. Okay. So I think I have clarified all of the basics. And now we'll try to move to the advanced part. Okay, I think this image. So clear, guys? Great. So please give me a like, all of you. Please hit the like. If this session helpful, guys, please hit the like, and if you haven't subscribed yet, so please try to subscribe, guys. So I need your support. Only I just need your support. Okay, nothing else. And this handwritten notes would be available also. So what I can do, guys, I'll just download it. Okay, I'll just export it, and I will try to share in my GitHub. Okay, and I'll add the link in the description. So in the description, you will try to get the resources link. So next class, guys, next session, we'll start the image processing. Okay, we'll export the OpenCV tool for the image processing. All right. Yeah, so I hope, guys, it was helpful, and this is the best introduction I can give, okay, to the computer vision. Now, if you have any feedback, guys, please try to let me know. Any feedback, guys, so that I can improve my lecture, or it is fine. Let me know. Your feedbacks matters a lot to me. If anything, do something for you, let me know. Next class would be like, see, I'll try to take regular basis, okay, but somehow if I miss the class, okay, let's say for some works and all, I'll reschedule the class, okay, but I'll try to take the regular basis, and here you will get the update, okay, in the playlist. Just try to open the playlist, guys. Here you will see the upcoming session, okay, upcoming session. So there you will see the date, okay, date and timing. So always try to check this particular playlist, okay, section, and try to subscribe and try to hit the notification, okay, bell icon. You will also receive the notification, okay, whenever live will start. All of you guys. So just try to subscribe and hit the bell icon, okay. So maybe I can open in a incognito window. So what you have to do, subscribe, okay, subscribe. After subscribe, just hit the bell icon, so you'll get the notification, okay, for the session. And let's try to hit, guys, 27k subscriber as soon as possible. Let's try to do one milestone also. Okay, so any question, if you have any question, let me know. Otherwise I think I can end the session. And how was the session, guys? How was the session? Did you like it? Let me know how was the session. Thank you, guys. Yeah, thank you. Thank you so much. Thank you so much, guys. Thank you. All right. So thank you, guys, for joining the sessions. Let's connect tomorrow. Okay, we'll try to start the we'll try to start the next topic, which is nothing but our image processing. Okay, image processing with OpenCV. A good one. I learned waiting for the more. Okay, thank you, Praveen, thank you, Faisal, thank you, guys, thank you, all of you, thank you, guys. So bye everyone. Always remember, consistency is the key. If you are consistent enough, definitely you will be able to learn anything. You will be able to get any kinds of success. So don't lose the consistency, guys. Okay, I have seen like many people will start with the introduction session, but they will not continue, okay, with other session. So please try to complete all the session, and this is my promise. After completing this playlist, you will be become champion inside computer vision. Okay, yeah, just try to be consistent with that, guys. Thank you so much. Bye everyone. Good night. Thank you, guys. Bye.